So I log Cloud Code out of all of my secret by just adding one line in my config file that don't read my .env, because all of my API keys, my database passwords, all of the other credentials live in that file. And you don't want an AI scraping that on its own. So I locked it and I asked Claude to read it. The lock held exactly like it's supposed to. Then just out of curiosity, I asked Claude the same thing but slightly in a different way. And lock is still on, but it handed me my key. And you know the crazy part? The lock wasn't even broken, I checked. Claude just walked around it because we are guarding the wrong door. And here's the part that nobody tells you when you start using AI agents to build faster. Claude Code has two completely separate ways to open a file. The first one is the native read tool. That's the door you think about. And that's the door you will always lock. And the other door is bash, your shell, where the agent just runs command the exact same way you would do your cat less grep. And when you wrote don't read my .env, you lock the read door. You never touch the bash door because you're thinking about the agent, not about your shell. And cat.env straight goes to bash. Let me stop describing this and just open the door for you. Alright, so here's our project. The deny rule is right there in our config file. Now let me ask Claude to read our .env. Access denied. That's exactly what the lock was supposed to do. But now let's change our gears and let me ask Claude to use bash instead. And there you go. All of our secrets leaked. The lock didn't really work because cat is a shell command and it went through the door that we never locked. The rule did exactly what it promised and protected exactly nothing that mattered. And before you think, fine, I'll just lock cat too, but there is less, grep, head, tail. There are dozens of ways that you can read file using shell. Lock one command and the agent finds the next one that works. And that is not security. That's a block list. And a block list against a shell will always fail. Alright, so far I was the one who was executing all of these commands manually. But here's the part that actually changes the whole threat model for developers. Because developers are not the only one who can run cat. Even their agents can run cat. Alright, look at this file. This is a normal source file in my repository. I have some helper functions and just boring stuff in there. But let's scroll down to the bottom and see this exact text. Well, that's not a comment for me. That's an actual payload. It's an instruction meant exclusively for your agents, formatted to look like a standard process checklist. Now just look at the binary that it cat. It forces execution through the shell environment. Whoever committed this didn't just guess. They targeted the exact execution blind in your config. And all it takes is one ordinary request from you that just summarize this file. Now, the agent will ingest the untrusted data. It will interpret it as an instruction and your keys will be exfiltrated to a path that you don't even control. And this whole attack is called indirect prompt injection. Not just a theory. A security researcher demonstrated this exact vector against Claude Code using a poison file to trigger unsandboxed shell commands and expose environmental variables. Anthropic later patched that specific exploit string from that disclosure, but the underlying vulnerability cannot be fully patched. And let me explain why that can't be fully patched. The structural issue is that an AI agent lacks definitive security boundary between its control plane and its data plane. It cannot differentiate between your commands and untrusted data inside a file it reads. You know, this is currently ranked as the #1 architectural risk for AI agents because there is no compiled malware. There is no complex exploit chain here and nothing for an SASCAN to flag. It is just plain text string in your repository that you cloned just 5 minutes ago. And you cannot reliably detect or interpret this at runtime. You have to enforce isolation at the operating system layer. You know, after looking at this, the immediate developer instinct will be to write more deny rules. But we just watched that fail. Because you block cat, the agent pivots to less, or maybe some other ways to read a file. You cannot win this with an exhaustive block list against a programmable shell where an agent can pivot to any other tool anytime. Alright, so let's talk about the fix. /sandbox, that's the whole command. And that's the only fix that you need. It's built on the same OS level isolation your browser uses to keep website off of your system. A deny rule is Claude agreeing not to do something. The sandbox is the operating system refusing to let it. And you know, it doesn't matter if the attacker uses cat, less, or any other command here. The kernel will always say no. Alright, so the same secret, now our sandbox is on and let's see what happens. Alright, blocked. Even before a single byte moves, I didn't make that attack weaker. I just enforce the structural isolation. Now the sandbox decide whether Claude can connect. Outbound traffic only routes to your explicitly allowed domains like GitHub, NPM, the stuff you usually use. And even if something got a secret in hand, there is nowhere to send it. And Anthropic built this specifically for this type of attack. And here's the workflow advantage. It cuts the permission pop-ups by almost 80%. And the secure architecture is the one that nags you less. Use it and take that as a win. Alright, here's the setup. The deny block secures the native read door. And notice, it's the glob, so it catches the nested files. And the .env.local you forgot. The sandbox secures the bash execution door at the OS level. And you always need both. Second thing that you can do is turn off your override settings. That lets block commands quietly. Alright, now let's talk about the fix. /sandbox, that's the whole command that you need to fix this. It's built on the same OS level isolation your browser uses to keep your website off of your system. A deny rule is Claude agreeing not to do something. The sandbox is the operating system refusing to let it. Now, turn off the override setting that lets block command quietly retry outside of the sandbox. Otherwise, you will left another door open. And the exact setting is in my checklist in the description below. Alright, secure the read tool, sandbox the shell, allow less the network. Just 3 things and this won't even take a few minutes. Alright, before I let you go, just one more thing. Because here is where this fails. Everything that I showed you is a local config file, which means any developer can change it, or maybe a compromise agent can even update it, which in turn will switch off all of your security layers. If you're not solo, then don't just rely on project file. Push this from the top as a manage policy, because when you do that, the config becomes immutable. Just one config and then your whole team is covered with zero cost. Alright, quick recap. Your .env lock is real, but it only guards the read door. Bash is the one and an agent will walk through it without you. Deny rules alone are just a block list. The sandbox is the floor that holds. The allow list stops the leak and manage policy makes it stick. Do that and you are nearly ahead of everyone shipping with these tools right now. I put the whole version into a one-page checklist. Every door, the exact config, the team rollout, and an audit you can run on your own setup. It's free down in the description below. And if you just got handed the job to make your AI tool safe, you can start there. Run it and tell me what it flags. I'm UD signing off. Until next one, the LLM Architect.